Hello everyone. In this video we are going to derive the law of sines. The law of sines is a formula, it is a method that helps us find out missing information about any triangle, not just right triangles. So to start we need an arbitrary triangle, and let's call it ABC. Now this triangle can be a right triangle, it can be an obtuse triangle. Doesn't matter what kind of triangle we are dealing with, and this formula will work for it. So here's just an arbitrary triangle. Call it A, B, and C. Now, so far the only tools we do have for triangles involve right triangles. I don't know if this is a right triangle or not, but to ensure that we have right triangles to work with, let's start by drawing in the altitude from vertex C. So dropping this straight down, that altitude creates a right angle with side AB here. This way I now have two right triangles to work with. Let's label this H for height, since the altitude is basically the height of the triangle. For my other side lengths here, pretty common notation where we use a capital letter to represent the angle, and then the side length across from that, we will use the lowercase letter so we get them to match. So B, lowercase b, and then here we'll say that's C. Okay, so now I have a right triangle to work with. I got two of them. This is the law of sines, so why don't we start with that? So let's do the sine of angle A for this left triangle here. So the sine is the ratio of the opposite side to the hypotenuse. So within this triangle, opposite to A is the altitude H, over the hypotenuse of this triangle is B. Let's do the same thing for our second triangle on the right. So we're going to do the sine of angle B. So opposite to angle B is the altitude again, and the hypotenuse of this triangle on the right is side length A. So now we have a couple equations that have A's and B's in them, but there is also the H in here. Now the H wasn't originally part of our triangle. We drew that in. So if I want my law of sines, if I want my formula to be easy to use, I don't necessarily want the H's in there. If it wasn't there, that would mean I'd have to go through all the work to find H every single time I want to do this. So our next step is we are going to eliminate the H. So I'm going to start by taking this first equation and multiplying both sides by B. That will isolate the H. So H is equal to B times the sine of A. And let's do the same thing with our second equation. Let's multiply both sides by A. So now we have two equations. They are both equal to H. So that means I can set them equal to each other. That's just an application of the transitive property. So B times the sine of A is equal to A times the sine of B. And now I have just one equation, just has A's and B's in it, and there are no H's. The next thing I want to do is I'm going to clean this up a little bit. So first, I'm going to divide both sides by B. That will simplify here. And I'm also going to divide both sides by A. So the B's simplify to 1, the A's here will simplify to 1, and what I'm left with is the sine of A over A is equal to the sine of B over B. And that is what our law of sines looks like. Now, I could do the same exact argument for another altitude in the triangle. So if I draw in an altitude from, say, angle A, do the same process. Now I can get angle C and side length C involved as well. So I can extend this like so. So this is our entire law of sines. If we look at the notation how this is laid out, we have the sine of an angle, and then on the denominator is the side that is across from it. Here it's the sine of an angle, the side across from that. The sine of an angle, the side across from that. And we don't necessarily need all three. We just list them off so that it covers all possibilities, so that we can use this with any combination of two pairs of angle, side across, angle, side across. Now the last thing, because of the way that these are notated, there are basically two situations where we can use the law of sines. So what we need is, if I'm just using two of these, I have four variables in here. I need to know 3 out of the 4 in order to use the law of sines to solve for that fourth one. So some combination of angles and side lengths. The first situation is if I know any two angles and one side. So any two angles, I can get my A and B, and then one of the sides, I would know one of the side lengths down here, and we can use the law of sines to solve for that last one. These are basically your angle, angle, side, or angle, side, angle cases. And the second case is if I know two side lengths and one angle. But the restriction here is that the one angle I do know, it has to be one of the ones that is across from one of the two sides that I know. So if we know two sides and one angle, and that angle has to be opposite one of the sides. Okay, so there we go. So here's your law of sines.